Part F.3, find the second smallest element. Yeah. All right. In this video, I want to solve one interesting problem. Find the second smallest element with n element array. Yeah. All right. So let me just write find the second smallest element in an element array. All right. Yeah. First, we did a special case for n equals 4. For n equals 4, we did it in one of the previous video when we find the median of 4 element. Median of 4 element array. At that time, we solved this problem for n equals 4. Because median, we mean the left median, right? Left median corresponds to the second smallest element in a 4-element array. Yeah. Do you still remember how did we solve it? We organized the 4 elements into 2 pairs. Then we do the comparisons, yeah. But here, we consider general n. Yeah. So here we consider general problem size n. Yeah. So we need to use a lot of abstraction. Although we use the same method, but we need to do a lot more. We need to use a lot of abstraction to get the answer, final answer, formula. Yeah. Here, the method we used. Yeah. So here I want to describe that method, the general properties. The method we used, it is called a tournament method. Yeah. Tournament method. I think you have the experience of this tournament method, right? Yeah, because, in sports, so it's frequently many, big competition events organized in this tournament method. Yeah. So basically, the players are organized in pairs. Each round, the losers are eliminated. Winners move to the next round. Then, remaining players organized in pairs. Another round, eliminate losers. Winners move to the next round. And finally, we get the final winner, the champion. That's the tournament, right? But here, we want to do the same thing. We want to do the same thing, and we can get the answer. We use this tournament as the model to organize our thinking. Yeah. So it's a pretty good model, yeah, because for each game, we use that to simulate comparison between 2 elements. The winner in our comparison, the winner, we mean the smaller element, right? Yeah. Because second smallest, the first smallest, that is the champion, right? Then the second smallest. Just next, second best below the champion. We want to find that one. Yeah. Although it may not be exactly the same as the real world tournament. Not exactly, yeah. But the model is already good enough, close enough to help us organize our thinking. So let us start. All right. So when we start, we have a sequence of elements. All right? Yeah. Array, n element array. Yeah. We can assume they have distinct values. Right? Yeah. Distinct values for convenience. So every round, one player must be eliminated. We do not allow tie. Okay? If there is a tie, then some special way, special games should be played to eliminate the weaker one. All right? Yeah. So at the end, then every comparison must have a winner and a loser. All right. Now we are ready to organize tournament. All right. In pairs. Yeah. All right. So x1, x2, the first pair. All right. So x3, x4, second pair, and so on. All right. Yeah. But when we do this kind of thing, first, because we consider the general n, you do not know n is even or odd, right? So some player may be idle in certain round, right? Yeah. It happens. Certain player is idle, just move to the next round directly without playing. Yeah, that happens. So it doesn't matter. We just try to organize the pairs as many as possible. So each round, only one player can be idle. Okay? We do not allow more than one player to be idle. Yeah. So, but here in our discussion, we don't want to get into the detail, try to describe which player at which round in the idle state, because that will be too complicated. So we don't want to get into that kind of details. Yeah. So that's the reason at the beginning I mentioned we need a lot of abstraction. Yeah. In our thinking, even we skip some of the details, we can still use some general abstraction way to get the correct answer. So don't worry. So we can still get the correct answer without too much details. All right, yeah. So let's move to the next round. So next round, here I do not need to specify, explicitly, so which one, yeah, right? I just draw a diagram, in a vague way, not precise way. We don't need a precise way. All right, okay, yeah. But in order to have convenient discussion, I may like to put the x1 as the final winner. How about that? X1 as the final winner. Yeah. All right. So just any player can be the final winner, but here just for the discussion purpose, I put x1 as the final winner. All right. So now think about in the first round. Not first round. All right. So to get a final winner, can you see how many games do we need to play to get a final winner? So here, the first question. How many games do we need to play to get the final winner? Can you see a quick answer? Can you see a quick answer? Actually, you should, because we solved a similar question before. Let me just remind you, we did this question. Find the minimum of an array with n elements. We did that. Find the minimum. Is that question similar to this one? Right? Similar. Minimum corresponds to the final winner. Right? Yeah. And our answer for this question, the optimal solution, n minus 1. Can we have the same answer here? Yeah. Actually, you can use the tournament way to get this answer easily. Why? Because each game, one player is eliminated, right? Each game, one player is eliminated, right? At the end, only the top player, the very top player left. The remaining n-1 players are all eliminated. How many games do we need to eliminate those n-1 players? n-1 games. Exactly n-1 games. How easy it is, right? So here you can see we do not really need to know which game eliminate which player, not necessary. We only need to know one game eliminates exactly one player. That's enough. All right, yeah. Okay, so we get the first answer, the second answer. Now our interest, we want to find the second best player, not the first one. First one already done. So this x1, the top best player. The next question, the second best player. All right, second best player. That is a little challenging. So here, for that discussion, I may like to, explore more properties. So here the goal, the current goal, all right? So the current goal, yeah, we want to find the second best player in the tournament. All right, in a tournament. All right. Question, how to do it? How to do it? All right, so here the property. So here we need to explore critical property. If you can observe that critical property, then you have a good chance to find the answer. Critical property. All right, that critical property, we used it once before. So in the median of 4-element array, we used that property already at that time. All right, yeah, but here, probably most of you forgot that property. So here, let me give you the general version of that property. Not that special version, the general version of that property. Okay, all right. So let me write this statement. You try to understand if the statement is true or false. All right. If a player has lost to a non-champion player, you know that, right? Yeah. Non-champion player. If a player has lost to a non-champion player, then this player cannot be the second best player. How about that? Can you see it? Then this player cannot be the second best player. Why? Because this player lost to non-champion, player. Okay, non-champion player. Then the player this player lost to is more qualified for the second best player, right? Yeah, so this one is not qualified because there is some non-champion player can beat this player. So that winner has better qualification. Right? Yeah. So this one should be eliminated. Yeah. This one, due to the, that condition, that this player should be eliminated from the consideration. All right? All right. Then, based on this critical property, then let me describe the candidates for the second best player. So next, we need to get candidates of the second best player. All right, so let me write that, and you try to see if it is okay or not. All right, yeah. Only the direct losers, direct losers to the champion can be the candidates. How about that? Direct loser. Yeah. The champion must beat that player directly. Okay? Yeah. Why I emphasize this direct losers? Because the champion cannot play with all the other players, right? Some of the players are eliminated, but they never play against the champion. There are many players like that. So we can call indirect losers to the champion. But there are some of the players, they are direct losers of the champion. Yeah. Right? So those players, they are qualified candidates for the second best player. Second best player. All right. Yeah. So then, all right. So now we are very close to the final answer. Very close. All right. Yeah. Okay. All right. Very close. How close we are? Yes, like this. All right. each round, the champion eliminates one player, right? That's the direct loser, okay? Yeah. One round corresponds to exactly one direct loser to the champion. It's slow because of the CPU thing. Yeah, a little slow. All right. Then how many direct losers to the champion? How many rounds do you have? Except the top, yeah, because the top, there is no round, right? Yeah. So how many rounds you played? How many rounds you played? Here, we need to estimate that number. Then we're almost there to get the answer, right? Yeah. Let's assume we have K rounds. How about that? Assume we have K rounds, okay? Yeah. But the K rounds, when people organize a tournament, they want to make the K as small as possible, right? Because they want to save resource. So they want to make all the players play each other, do the eliminations, but at the same time, they want to make the rounds as small as possible. But still, all those rounds should cover all the players. All right. Then, when we look at the first round, there could be one player idle. So each round, at the most, one player idle, right? Each round, at the most, one player idle. But when we look at the first round, can you see the total number of player n should be less than or equal to 2 to the kth power? 2 to the kth. 2 to the kth. Yeah. 2 to the kth. Okay? Yeah. Because when n equals 2 to the kth, then no player idle. Yeah, from beginning to end. So the perfect grouping. Yeah. We cannot require that perfect grouping. Yeah. So we have this because there are many idling cases. So we allow that. So we want to find the minimum power of 2 that is greater than m. All right. So with that, so k equals floor function of log base 2 of n. All right. Okay. That means there are this many direct losers. Number of rounds, right? This many direct losers. Yeah. From the direct losers, we want to find the best one. How many comparisons do we need? From direct losers, we want to eliminate all other people, only one left. The answer is k minus 1, right? Yeah. Then, from k direct losers, get the best player, we need a k minus 1 comparisons. All right, now we are ready to get a total comparison for the whole problem. Okay, all right. So that is n minus 1 plus k plus 1. K minus 1, how about that? N minus 1, that is the champion part, all right? After that, we identify all the direct losers. So then, from those direct losers, we pick the best one, k minus 1 more comparisons. So finally, the final answer, m plus k. What is k? Floor function of log base 2 of m minus 2. All right, that is the final answer. How about that? The solution for the general problem. Find the second smallest element of an array with n elements. So that's all we have. All right, so let me finish this video, F.3 right here.